In this video I want to show you how to set up your flight controller with INAV, then load our provided VTOL diff on your flight controller and connect it to your 2X and do the first hover. If there should be any questions, please write them down here into the comments. My team and I will answer them as soon as possible. Also, every other user who is comfortable with INAV can help you exactly here into the comments. To get the latest diff files, just visit our website aerojtp.com, then go here on PDF downloads and you will find it on the bottom of the page. Here are the diff files for INAV, for Crossfire and for FrSky. So this is what you find in your folder. The INAV file, the print files, some print profiles for different printers and also different slicers, and some notes, the instruction, wiring diagram, parts list. And here I already put the trestle, the horse, into the Bambu slicer. Something you could notice on the material, there could be written generic PLA, because the data is not loaded, but it should be the lightweight PLA. To check it, just go here on material and you should have the same data, especially the flow ratio 0.59 and also the print temperature 259. And the bed temperature. Here could be also something mentioned from Bambu Lab, maybe that the bed temperature is too low, but 22 degree on all the upper layers is absolutely okay. It saves you a lot of energy, and also the adhesion on the Bambu Lab plate is so superb, so you can get down after the first layer. So let's take a look to the printer. Here we are in the printing room, and the Bambu Lab is already printing our trestle. Here we can take a look. This is the part, and take a look inside. It's also printed from lightweight PLA. Some super important thing why lightweight PLA printing is the temperature, room temperature, and the humidity. And here we can see them. At the moment we got 15 degrees Celsius and 51 humidity. This is not the perfect temperature for lightweight PLA. That's why all lightweight PLA is stored in these dry boxes like the AMS, and you can see here we just got half, we got 27%, and the print temperature in the room inside is here 25%. So this is just perfect for printing, but when you got an open printer like this one, it is better when you heat up your room. This is just a trestle, so this is no big deal. But when you print your airplane, then room temperature 20% and humidity also 20 degree and 20%. So 2020 you can imagine. And store all your material in these dry boxes. You see here I reach super low humidity. You also can dry your material in these dry boxes. Your print quality is much more better when you got dried lightweight PLA. So, and let's take a look on the printed parts. Here we got rear fuselage parts, and for removing supports from deeper holes, I'm using this breast tube. Here, put some sieves on it. This helps, and with this breast tube you can easily go inside and clear them from any support. And what I'm also using is this combination of knives, just small knives, or here these whatever. This really helps to remove any kind of support. And for bonding, I'm using medium super glue and this accelerator spray. And sometimes, if you don't want to bond something on your wooden surface, just this plastic film. Maybe when you bond two parts together, put down your plastic film and everything works nice. So let's take a look in the manual. Here we got every steps shown for us, where you put in the carbon rods and went into, and all the details you will find here. And let's take a look on the wing, for example. And here we got the wing, for example. ready built. And let's take a closer look what we got here. This is, for instance, the servo reverser, and here is the power cable with the connector. And let's see how this works. This is how the doors work without the servo expander. So, and with the servo expander, this is this yellow module included. You see the doors open and close completely. So, and here we can see the same on the wiring diagram. Here, for instance, the wing cover servos, these two servos, and the reverser. This is what we got here, the two servos and the reverser. And all at the end, where all servos come together on the servo divider, we got the servo expander, that we just need one of them. And this expander ran into the flight controller. So here we got the controller with all the inputs, and we can see on S9 we got all the doors. And let's go over to the jet. So, and here I already pulled out the connector from S9, and we go manually to this connector with the servo tester. So now we can move the doors manually. And before you connect any channel to the flight controller, make sure that it works correctly. Later on, all these settings that the doors close correctly, you do with this pan heads, with this ball heads. This is done manually. We got a fixed output on the flight controller. So before you connect anything, use your servo tester and run them manually, that everything opens and closes correctly. Also check the current. That's also important. Here we got altogether six servos, and you can see the current here runs up to 1 amp, or over 1 amp, 1.3. And make sure when all the doors are closed, now it is an idle about 130, that when everything is closed, the current shouldn't rise above 300, let's say 300 milliamps for 6 servos. Otherwise, you have to adapt the length of all the connections. Yeah, when open is the same, you see open I got 260, 250. When all doors are completely open, it should also run not about 300, let's say maximum 500 milliamps for the servos. So now let's take a look on the tilt servo. I remove the cover, and here we can see it. This is a stronger servo, and this tilts the whole EDFs. Now they run not exactly to the end position, because it runs just over my servo tester and not over the flight controller. But we also can see here the current. So check that the current doesn't rise in the end positions over 300. And we also check that this leg is running the same. They are both coupled. They run the same. And let's have a look on the wires, that the wires run correctly. You see, I attach them here with a cable tie, so they run from here to there. And here I use also this spiral tube. This spiral really helps that the wires glide nicely all along when they touch anything, so that nothing gets stuck. And also make sure that the wire is long enough that nothing get pushed. And at the end, I was using these 3.5 millimeter banana plugs or bullet plugs to keep everything detachable. Make sure that you put on some spots some super glue between the EDF and the EDF holder, because it could be that the EDF is slowly moving forward on full throttle, even if it is squeezed into the EDF adapter. So on 3 or 4 points all around, just put a drop of super glue. So let's take a look at the vanes. This is the neutral position, and this is how they can run to left and right for maximum authority. Make sure that you put some drop of super glue at the ends of this carbon rods, that nothing can flip flip out. Everything should run easily, so don't put these screws too hard. So, and this is how the range should move. This is maximum travel. You see it's about 40 degrees to each side for yaw. And make sure, go to 0, David. And make sure on 0 position the vanes are vertical to the downside. This is very important for your first start. So David is preparing everything for the INAV manual, and in between we take a look on the printer. So the Bambu Lab doing a great progress, and I just can recommend you the Bambu Lab printer. It is the most easiest one. You got less trouble. All the other printers are really not bad. I really like them. But it takes much more time for the setup that you got a perfect print result. And here we just put it on, load our settings, and everything works. And also the changing of the materials. It is the most easiest material change of all the printers you can see here. This AMS is absolutely great. And if you like to get a Bambu Lab printer, use the affiliate links underneath in the video descriptions so you can support our project. And it costs you nothing extra, and you will have a wonderful printer. So now we get INAV. So, and to getting this, you just go to Google and type in INAV.
Yeah, configurator.
INAV configurator. Okay, perfect. So, and this is where you're getting.
Yeah,
on the GitHub. Click it. Oh, and we are on 8 already, okay?
No, you need to. So firstly, you need to select the stable release of INAV. For doing this, you go to tags and then select currently 7.1.2, and then you scroll down and select the INAV configurator for your operating system. So we are here on Windows, so you need to select Win64 7.1.2 and wait for the download. So after you've downloaded INAV configurator, you install it. Accept the agreement. Select your installation folder. You can just use the default one, and then click on install. After the installation is finished, you can open INAV configurator, and then you need to connect the controller. You need to connect the controller with your computer, where INAV one's on, so the configurator one's on. Then wait for Windows that some COM port opens up here. And then you need to go to the firmware flasher and flash INAV to the controller. If you are lucky, INAV will detect the controller type. And then, or you have to select the right controller. And then you need to select the latest stable release of the firmware. At this time it is 7.1.2. You have to select a file ship erase, and then you can scroll down and select load firmware online and wait for INAV to download the firmware. After that, you just click on flash firmware and wait for the INAV configurator to flash the firmware on the controller. Now INAV configurator is erasing the flash of the controller to flash the new firmware. Now INAV is flashing the firmware. You can see it by looking at the word flashing.
Was meinst du jetzt, welchen Treiber?
Den Treiber für den Controller. Then after INAV configurator has flashed the firmware on the controller, you should see programming successful. If not, you should try it again. Maybe by selecting no reboot sequence and then clicking on flash firmware again. But here the INAV configurator has flashed it successfully, and so we can go to connect on the top right of the INAV configurator by clicking on it. And then you can just INAV, the configurator will ask you if you want to set default values. You can just go to keep current settings because you will now flash the diff we will provide you on our website. So now you go to CLI that's on the bottom of the menu, and select Load from File. You now need to select the div we have provided you. And click on Open. Then you click on Execute and wait for the configurator to flash the div, or to program the controller. That's a better word for it. Then the INAV configurator will reboot the controller, and now you should see some icon, or some image of the plane, or of the plane in drone mode.
Now we want to connect the receiver with the flight controller, and at first we go to MatrixSys, to the web page, and look for our explicit controller. This is the H743W Lite, and we select this, and here we find all the information we need, especially where to put on the connector for the receiver. And here we can see everything, and especially where to put on the receiver. So something important to notice is when you connect your receiver with the FC, connect TX from the receiver with RX from the board, and also the opposite, RX from the receiver with TX from the FC.
After you have bounded your receiver successfully with your transmitter and connected the flight controller with it, you should see on the receiver tab in the INAV configurator that when you move some sticks of your transmitter, the flight controller receives the input values. If not, you have to change the receiver type to serial, and your serial protocol to the right protocol of your receiver. For example, we are currently using Crossfire, and so we have to select the Crossfire protocol, which is the first one. In our example, we have got a Radiomaster TX16S running HTX, and for creating or connecting our jet with the transmitter, we have to create a new model. We do that by go to Manage Models and create a new model, select a blank model, and then go to Model Settings, connect our receiver module. In our example, it is a Crossfire module, so we have to go to Crossfire and connect the receiver. We have to select a new unique ID, like this one, and then connect the receiver by going to radio settings, and then by going to our Team Black Sheep agent and bind our receiver. So after you have successfully bound your receiver with your transmitter, you can go to your settings for the transmitter inputs and have to add two switches. One is the arming switch, which is a two-step switch, which has to be on channel 5. This switch is used for arming INAV. So it's like throttle cut in neutral position. After you have added a two-sided switch, which is the arming switch, and the switch has to have -100 as the default value, which is throttle cut in INAV, and a 3-step switch would also work, but you need to make sure that in the neutral position the value is -100. You can add another switch.
So after you added the arming switch, this one, we also have to add the VTOL switch, super important switch, to make sure this is one you can super easy reach. So we use the one on the left side. This is much easier to reach than on the right, because you have to steer there the model. So I think this is a super position. And on which channel we have to add this switch?
On channel 8.
On channel 8. So this is super important the arming switch channel 5 and the VTOL switch on channel 8.
So we recommend you that you set the transition switch to, and that you invert the transition switch so that when the switch is down, the plane will be in VTOL mode, and when the switch is up, the plane will be in plane mode. So it's easier for you to remember the right position of the plane. Then for the transition mode, you have to do one important thing, which is the delay in the channel of the transition switch. So you have to slow down from 100 to minus 100 the channel to 5 seconds, and slow up the channel from minus 100 to 100 in 2 seconds, so that the flight controller is in the transition mode for about 4 seconds, which gives you enough time when the plane transitions from VTOL mode and plane mode to control the plane.
So, okay, and now we want to show you what this delay looks like on the real airplane. Now we want to go from drone mode to flight mode. Okay, David?
And you can see that the transmitter will slow down the transition from 100 to minus 100 in 5 seconds, which gives you important time to that the plane will be stable in the transition mode.
Yes, exactly. And the other way from flight mode to drone mode, let's take a look at this. This is just 2 seconds. It's much faster. Of course, it's a much faster transition. So we got these 2 seconds from plane to drone and 5 seconds from drone to plane. So now we want to configure the telemetry, and let's take a look, David. How do we do it?
You go to model settings, go to your telemetry settings in HDX, which will show up.
And they show up automatically, yeah. So all the time when the 2 connectors RX and TX are connected with the receiver, all telemetry is already sent to the transmitter. So we just have to select that they are shown on the display.
Yeah, but you may click on Discover New on HDX depending on you've got all the telemetry settings, which should be 24. So after that, you go to your main screen and go to Screen Settings in HDX and set up your widgets. We have set up the layout with 4 rows on the left side and 2 rows on the right side, and yeah, then you can go to set up widgets. Important set value you may want to see is the battery.
Yes, we want a capacity, current. So now telemetry is ready configured. We got the capacity. This is super important that you know how much is left in your battery, and the voltage and also the current. Okay, David, let's give a bit power.
So 3 amps.
Okay. Yes, it's working. Now we want to calibrate all the ESCs that all the motors start at the same point. And for this, you have to switch off your battery. So battery off, and connect the computer with INAV, or connect the computer with the board. Okay, and now David will explain in details what you have to do.
So for calibrating the endpoints of your ESCs, you have to go to Outputs in the INAV configurator and toggle the switch that you understand the risk that the propellers are removed and yeah, that you want to enable motor control. Now you have to select one motor and power the motor fully on, so set the percentage to 100 of the motor, and then you have to connect the battery.
So you see now we have the propellers on, but we recommend you remove the propellers. Remove really the propellers from the motors We did this sometimes before, so we got some training, but when you do this for the first time, to save yourself, remove all the propellers. Okay, now we put on the battery.
Yeah, and wait for the ESC to calibrate the endpoint position. Yeah, for our ESC, that is was the signal that he detected that we have set the highest endpoint, and now you have to go to INAV, to the configurator, and set the throttle to 0%. Wait that your ESC registers the lowest endpoint. Now the ESC is calibrated.
So, and the same procedure you have to do for every motor separately. You heard the sound. This is what you need to hear. And then all the engines are calibrated and start and stop at the same moment. And this is what we need for a good stabilization on drone mode. So, and now we want to do the first real check. We want to check if the propellers turn in the correct direction. For this, we have this layout here. This is a top view where all the props, which shows up which direction they should turn. And we also want to see if the correction or the stabilization from the board works in the correct way. This means when I roll to the left, there should be running the left motor to pull it back. And this we want to check now. So we disarm the motors and give a little bit throttle. So this is something maybe you have to feel. Yeah, you saw what we did. It really helps when you got a buddy, some friend of you that is always on the TX to cut off all the motors, yeah, all the arming switch, just the arming switch on disarmed, that everything shuts off immediately. Super important. Yeah, and at first you take a look on the rotation of if the rotation is correct, and when the rotation is correct, you can start rolling with the jet, and you will feel it. You will really feel it because they are powerful. You will feel that a force pushes up the wing again. And the same you do with pitch. Yeah. So when you pitch the fuselage forward, okay, David, we can go. When you pitch forward, the front motor will spin up to stabilize, to create a force against it. And when you pitch the rear, when you pitch or press down the rear motor will spin up or spool up and will press against it. Yeah? So you have checked if the flight controller acts in the correct way. The last is a yaw, and for yaw we can do it without the engines. You just turn to one side, and this side you turn it, and this side also the two vanes have to move. So when I go to this side, you see the vanes go also in this side, and this will create a stabilization force that the plane is moved back and stays in position. So this is here super easy to see. Yeah, you go in one direction, vanes move in the other direction, and after this the vanes should come in the neutral position again. So now we want to simulate the full transition to see if everything works and also have an eye on the current. Yeah. Now this is a real power test, so I would recommend you to use some safety glasses just to be sure that nothing goes wrong, and make sure that you blow something where nothing gets destroyed. We will blow to this window. Das Bing hören?
Yes,
this one. Yeah. So now we start. First we arm the engines, and then we give slowly throttle. So, and you heard and saw it. We did a full simulation. Nothing burns. There's really a lot of power is consumed. And for this transition, we used 485 milliamps. And the maximum current, I think this was 150 amps. But there we can take a look again. Okay, David, come to me again. And we do one time. Okay, Henry, you can push again. Push. And first we take a look again on the horizontal thrust. This is now just horizontal. We do the back transition. For the back transition, we just give about half throttle. And we can see how it rises. And then transition again. And when this works, we are nearly ready for the first flight. The last thing we want to check is if our elevators and vector nozzles move correctly. And there we do the same like before on all the fans. We move the plane, and when we roll to this direction, the correction must go that this moves down with the tail. This moves down to push it against this roll. You see the same. And when I pitch up, the elevators have to pitch down for the correct way. And when I pitch down, they have to pitch up. And the same for yaw. Yaw is just a very little bit. We set yaw just a little bit for a good flight behavior. So you can't see it that much, but when I move to there, also the nozzles move in this direction. Yeah, maybe you can see it here. This is the same like with the vanes for your the explicit force against it is in the same direction. Okay, and when everything works, finally we can do our first test hover, and we will do this here inside. For this I need a new battery. So now we want to show you something special. Maybe you saw in the last videos when we have a lot of headwind and we don't want to pitch too much the whole airplane. So we installed a special mix. And this mix, when you pitch forward, you see that the main EDF gets tilted. So we got not just a vertical vector from the main EDF, we also got a forward vector. And this helps us to hold position again, strong headwinds without tilting the whole airplane. Yeah. So just that you know, when you are in drone mode and you pitch forward, the main engines sweep also a little bit. Yeah. This is just forward, not backwards. Backwards we don't need this. This is just on pitch forward. Okay. And now we are ready for the first hover. Now we want to do our very first hover and also have a look on the current. So I arm the engines. So, and then I give slowly power. Now after this hovering, we have a look on the temperature from the engines, and they rise to about nearly 50 degrees. This should be also the max that they don't melt the PLA. So yeah, 50 degree, 51 was the maximum, 50 Celsius. So when you hover for a longer time, give them a small break to cool down. This is just for not melting the PLA parts, or you print these adapters with more temperature resistant material. This would also be possible. Yeah, and this is how you can start learning hover. And when you feel safe with the hovering, you can rise up to about 20 meters, like you saw on my first attempt also, and then just press the switch and fly forward. And for the retransition, you can land on the skids if you don't feel comfortable. I'll show you just for a moment. Here you see you got switch under there, skids under there, where you can land on. This is no problem. Just make sure that you are in airplane mode, or if you want to do land vertical, just go to vertical mode and land like a drone. So now let's talk about flight controller and periphery. Here we got, for instance, the GPS with a magnetometer. We used this at the very first time, but we didn't saw any advantage that the copter was not more stable or didn't hold better position. So we doesn't use it anymore. But if you like to use it, you see here you have these two big compartments. This, for instance, could be installed here, the magnetometer. On the STLs, you got for every part specific holder. Also, it is detachable with some screws, so you can install here the plates for the magnetometer or for your decent receiver. And next, let's talk about the flight controller itself. You know, in this jet, we got the Martec one, Martec H743W Lite, but we also used in the first flights the SpeedyB F405 wing, and we want to show you now why we decided finally for the Martec board. The main reason was the BEC output. Here we got on the Martec board 8 amps and maximum 10 amps, and on the SpeedyB, like you can see here, we just got 5 amps, so this is really a lot less. And you know, we got a lot of servos, and especially while transition, when there is a lot of force on all these servos, maybe 5 amps could be a little bit less. And the next reason is we got 1 PWM output more on this board. So if you like to add some special function here more, it is possible with the Martec board, which is not possible with the SpeedyB. There we would need all outputs. So you can use it if you already have the SpeedyB, but be cautious with your BEC. And a third choice would be the Holybro K-Coot H743. You can order this with the pins already soldered, which is a very cool fact. And we got almost the same specs like on the other boards. For instance, here the maximum current. This is also 90 amps continuous, 220 peak. This is for all the motors. And let's have a look on the output for the servos. Here we got 6 amps continuous. So this is even more. This is even more than on the SpeedyB. Remember, on the Martec board we got 8 amps continuous, 10 peak, and here we got 6 amps continuous, 8 peak, so just a little bit less. And I think this would be also enough. And we got altogether, I think, 13 PWM outputs. David, is this correct?
Yeah, 14. Yeah.
14? Where was it? Here, 14. We got altogether 14 outputs. This is also 2 more than on the Martec and 3 more than on the SpeedyB. Yeah, so for all the upcoming projects, and or if you like to add something special,
Landing gear.
yeah, I would recommend the Kakut board. We also will test this maybe next year. You know, now it's winter, so we don't do this in the next months. But I think these are the three best choices. Yeah, first choice I would say the Mate because of this powerful BEC. Second choice the Kakut, and the third choice would be the SpeedyB. So now we want to show you how to configure the FrSky, just the X20S, the receiver configuration.
Yeah, firstly you go to HF system, then add a receiver and bind it. Then you go to options and set on pin 1 FBus and on pin 2 FBus. Yeah, that's it.
Oh, it's S-Bus, ne? One is S-Bus.
FBus.
Yeah.
No, S-Bus not. You ignore S-Bus.
Ah, okay,
Just
okay.
pin 1 and pin 2.
Ah, understand.
To FBus.
F-Bus, both S-Bus. Now I see it also.
Yeah.
Good. And this is a SR10 receiver, if I remember this correctly, yeah? Was it?
SR10, yeah.
Yeah. SR10 plus with, this way, SR10 plus receiver we got here. Okay.
Yeah, maybe I will also show you how to set up both switches. Yeah, you first have to add the ARM switch, which is just a normal switch. Yeah, it's just configured as a normal three-sided switch in this case.
Yeah.
And without a delay, and the transition switch is also on channel 8, like on the Radio Master. And this one has the delay of 2.5 seconds from 100% to 0%, and from 0% to minus 100%, also 2.5 seconds. So in sum, it's they are 5 seconds.
Yeah, at the end it's the same, but
Yeah,
but this transmitter is just calculating from one end to the other, while the Radio Master is just calculating one half. So,
Yeah, exactly.
But the whole time is all the same. But just remember, here you got 2.5 and 1, while here you got 5 and 2.
Yeah.
Okay.
Yeah, that's it. Yeah, that's it. Then you can see the transition time.
Yeah, that's running.
And that's the 5 seconds.
Yeah.
Yeah.
Okay, and now we can go over to INAV to set up the flight controller for the FrSky.
Yeah, FrSky.
FrSky.
Yeah, for this one you have to set in the receiver tab on receiver mode, serial and FBus as the serial receiver provider. And you turn off the inverted serial port and turn on the serial receiver in half duplex mode. Yeah, and then click on save and reboot, and that's it. Yeah.
Okay, and that's all here.
Yeah, that's all.
That's all.
Yeah, maybe you want to see how one would configure the telemetry.
Yeah.
There you can go to find sensors and turn it on. After that you will also have all the sensor values of the flight controller, but we had to add the use capacity, which is a calculated value from the current. The current is FASS. And yeah, for doing that, you just add a calculated value by going to adding a calculated value and then using as the source FASS, and yeah, as the unit milliampere hours, and that's it. You would add it, and then you have the additional use capacity. Yeah.
Okay. Special thanks to David and Henry. This was again a super funny day with you guys, and I'm looking forward to the next cool projects in the upcoming year. I think they will be awesome. So I hope you enjoyed the video, and we will see you in the next one. Bye bye.